Okay, we learned that the copper sulfate was the limiting reagent, and we could only make 7.95 grams of the copper phosphate. So there's going to be some leftover phosphate because it's the excess reagent. Now remember, this is an ionic solution and salts are electrolytes. So really we should be looking at the net ionic equation. So we have 3 copper plus 2 plus 2 phosphate makes Cu3PO4 2 as a solid. This is our the actual chemistry that's going on, and the sodium ions and the sulfate ions are spectator ions. And we want to ask ourselves how much phosphate is left over. Now, for every sodium phosphate, there's 1 mole of phosphate. So we know that we start with so the amount left over, the phosphate excess is equal to the phosphate initial, how much we started with, minus the phosphate consumed by the complete consumption of the limiting reagent. So we started with 0.05, and I'm going to leave out the 00, but we have to use that in our significant digits, moles of phosphate. Can you close that, please? We then consumed, we had 0.06265 moles of copper. And we hadn't that many moles of copper because 1 mole of copper sulfate has 1 mole of copper and 1 mole of sulfate. So the copper concentration is the same as the salt's concentration. Now, from our stoichiometry, we note that we use 3 moles of copper for every 2 moles of phosphate. So that we have 3 moles of copper plus 2 for every 2 moles of phosphate minus 3. Okay? Now this number here, if I go out and do my math, would be equal to 0.04177. And if I take 0.05 minus 0.04177, I come up with 0.0082 moles of phosphate left over. Now the question was, what was the concentration? So I have to ask myself, what was the volume that this mole is dissolved in? And we have 500 mils, which is the equivalence of 0.5 liters. And this comes up with a value of 0.0164 molar. Now, notice that when I subtracted this number from this number was really known to the 10,000ths position. So we truncated this number to the 10,000ths position. It now has 2 significant digits. This number, although I wrote 0.5, it has 3 significant digits. So the correct answer would be 0.016 molar because this number was only known to 2 significant digits. Okay? And remember, molar means moles per liter.